Today, on how it's made. Patterned glass panels. Road cases. And stop frame animation. Used for windows, doors, and partitions, patterned glass panels add beauty and light to a room, but their purpose is more than decorative. The designs in the glass also obscure the view, making patterned glass an effective privacy screen. They let light in and keep prying eyes out. With patterned glass, windows become something to look at rather than through. There are a variety of designs and textures to choose from, offering different degrees of privacy. At the heart of the process are engraved metal rollers that transfer designs onto glass. Before production can even begin, this roller rotates through a chamber where grit blasts off grease and dirt. If the designs on the roller are damaged, they shave off the outer skin, exposing a smooth surface for re-engraving. But that isn't always necessary. Small problems can be fixed, so they circle those for repair. Some need no refurbishment whatsoever, so they move on to the next step. A worker brushes a polishing compound onto the printing roller. A buffing wheel rubs the compound into the roller's chromed surface, taking it from dull to a high shine. Meanwhile, in another part of the factory, craftsmen repair trouble spots on other rollers. The work has to blend in perfectly. The craftsmen do their jobs with the finesse that comes from natural skill and years of practice. One false move, and the entire pattern could be ruined. But the touch-ups are perfect, and these rollers are now ready for the production line. The raw ingredients for the glass panels are stored in huge silos. These ingredients all come from the earth: sand, limestone, dolomite, soda ash, and salt cake. Here's a sampling in a jar. Conveyor belts feed a mixed batch of ingredients to a roaring furnace. They add waste glass and recycle it into the process to reduce the effect on the environment. Fired at 1600 degrees Celsius, the ingredients melt quickly. Now a molten mass, it circulates in a looped pathway. An inspector checks the melting status of the glass ingredients, as well as the flow of gas fuel to fire the furnace. This furnace is burning 24 hours a day, 7 days a week, and is monitored constantly. The hot liquid glass now flows between two rollers, one of them engraved. The rollers imprint designs onto the glass and squeeze it to its final thickness. The glass rapidly solidifies, fixing the pattern in the ribbon of glass. Then it travels through a 60-meter-long temperature control zone. The glass ribbon is exposed to flames to relieve stresses caused by the manufacturing process. This is called annealing. The glass slowly cools as it leaves the zone. This seals in strength and durability, so it can now be cut cleanly without fracturing. This cutter scores the glass lengthwise, but doesn't cut it all the way through. The scored line maps out the desired width of the glass. Another cutter moves to and fro to create horizontal score lines. These lines establish the length of the patterned glass panels. Then a roller pops up and breaks the glass along the horizontal score lines. The sides of the glass now collide with little wheels known as bonkers, which snap the glass along the lateral score lines. The waste glass falls down a chute to rollers that bust it to bits. These bits are called cullet, and they'll be recycled into new glass. A worker now backlights glass panels and examines their finish for flaws. This solar glass panel has a matte finish. Compared to the small sample of standard clear glass, it's less reflective, allowing more of the sun's energy to be captured. Minerals high in iron produce greenish glass that's light absorbent. For solar glass, they go easy on the iron to produce white glass that transmits light. A carrier with suction cups stacks the glass for shipping. Now all that's left is the window shopping. Road cases are designed for the job of transporting sensitive equipment like musical instruments and audio systems. These wheeled trunks are tough on the outside with cushy foam on the inside. With road cases, the gear arrives intact and ready to rock and roll. Behind every superstar, there's plenty of this custom luggage. Each case is designed for a particular piece of equipment, like an audio mixing console. The case is being made to measure. They load the dimensions of the audio console into a computer and then design a virtual case around it using three-dimensional software. Once a customer approves the computer blueprint, they're ready to build. Workers roll adhesive onto thick birch plywood. They coat the entire sheet. The plywood is now ready to receive a thermoplastic outer skin. They align the thermoplastic with the adhesive-coated plywood and lower it into place. They feed the thermoplastic and plywood layers to rollers that squeeze out any bubbles for an airtight bond. Then the heat from this hot press activates the adhesive and it cures for an even better bond to the plywood. The result is a laminated thermoplastic plywood sheet. Next, a computer-guided router carves through the laminated sheet, following the design drawn up in cyberspace. This produces the exterior panels, each one precisely sized for the audio console case. The router also cuts out holes for latches and other fittings. A worker pieces together the panels to form the basic carcass of the case. He tacks them together temporarily with a staple gun. He'll join them permanently with extruded aluminum trim. He preps the aluminum edging by punching rivet holes in it at strategic locations. He also cuts notches for bending it around corners. He's now ready to install the aluminum trim. He can actually bend the corners by hand for a perfect fit. The edging gives the case a tailored look, and once riveted to the panels, it will hold it together. He drills through the holes in the trim to make corresponding holes in the laminated plywood. He inserts rivets into the holes. These rivets have mandrels attached to them. He drives those mandrels through the rivets, causing them to expand around the drilled holes and secure the trim to the trunk. With the job done, the mandrel breaks off and is disposed of. With the case now held together by the metal trim, he rivets the latch to it. And then it's on to the inner framework. The plywood parts have also been cut with computerized precision, designed to hold that audio console. He reinforces a piece called a cheek with a thick block of wood. This cheek is one of two that will cradle the audio console. He bulks up the wide end with plywood copies of the cheek's contoured profile, gluing them and nailing them to the main part so this reinforcement job holds. He spray paints the cheek substructure black, giving it a durable, textured finish. He fits the cheeks in the case, one on each side, and bolts them into position. Another worker hot glues blocks of foam, each specifically cut to fit together like pieces of a puzzle, as he installs them in the case. All this padding will cushion the impact of any bumps on the road or backstage jostling. He even covers the top of a plywood drawer made for a keyboard. They slide the audio mixing console into the case to try it for size. From start to finish, it's taken about 3 hours to make this road case. It should last for as long as the audio equipment does, but it all depends on how rough it gets on the road. Many animated films and TV shows use stop-frame animation. The characters are three-dimensional puppets with movable facial and body parts. The animator moves the puppet ever so slightly for each frame of film or video. When you view the frames at regular speed, the puppet appears to be moving. Bringing a make-believe world to life through stop-frame animation takes a large and talented team, which includes writers, directors, animators, set and prop makers, camera crews, and of course puppet makers, who create, maintain, and repair the puppets. To see how stop-frame animation works, let's rewind this scene, which stars Timmy and features a red balloon. The director takes the writer's script and breaks down each scene of the episode into a series of shots. This shooting script then goes to the storyboard artist, who draws each shot of the scene on a digital storyboard tablet. For each scene, the director prepares a set plan, detailing the background elements, the puppet placement, and the camera angles. The storyboard artist sends his drawings to the editor, who works with the director to edit them into an animatic, a still drawing version of the episode. Actors, meanwhile, have recorded the dialogue in a sound studio. Now the editor cuts that dialogue into the animatic. The visuals and this soundtrack must be perfectly synchronized because the animators will use the animatic as a frame-by-frame guide for moving the puppets' bodies and lips. The show's animators refer to a large schedule board to see which scenes they've been assigned to animate. A printout of the animatic shows all the episode's shots at a glance. In the art department, construction of the episode's costumes and props is well underway. To make a few red balloons, for example, the prop makers sculpt one out of modeling material and use it to produce a hard silicone mold. Then they pour quick-setting resin into the mold cavity. After the resin has hardened overnight, they open up the mold and extract the casting. They drill a hole in the bottom, dab some glue inside, then insert a small triangular peg, also made of quick-setting resin. This forms the tied bottom end of the balloon. Now a coat of grey primer, and once it dries, red paint. When the paint dries, they drill another tiny hole at the base of the balloon and insert a strand of flexible copper wire wrapped in cotton thread. This is the balloon's string. The team of animators shoots several scenes concurrently. Therefore, in the puppet department, model makers produce multiple puppets for each character, plus lots of extra body parts. Certain puppet body parts, such as hands and wings, are made of silicone, with a wire skeleton within. After forming the wire to shape and applying a base coat of silicone, the puppet maker lays it in a two-part mold, then fills both cavities with silicone. She closes the mold, clamps it tightly shut, and leaves the silicone to set overnight. The flexible wire skeleton at the core enables the animator to position the hand or wing various ways. In stop-frame animation, the more movable the puppet and its facial features, the more lifelike the animated character appears. The animator moves the puppet incrementally for each frame they shoot, and 25 such frames produce just 1 second of animation. Timmy's torso is a polyurethane foam core dressed in a wool coat. It has channels for interchangeable wires which support his head and arms. His head is made of resin. His arms, silicone over a wire skeleton. Timmy and his friends' faces can express a wide range of emotions thanks to interchangeable mouths, flexible ears, and blinks, an assortment of exchangeable eyelids conveying expressions from wide-eyed to cockeyed. These facial features attach either magnetically or with tacky wax, a flexible, quick-release glue. The puppet maintenance team packs each character and its parts in a travel box, then sends it to the animator on the studio floor. During shooting, the animator changes the facial expressions as required. While their work does indeed require great technical skill, the animators are actors who, under the director's guidance, perform through the puppets they bring to life. The puppet's legs must be sturdy enough to support the weight of the upper body when the puppet is standing, so the leg skeleton is made of metal rods connected with ball and socket joints. The feet are metal plates, hinged to allow movement. Just like the flexible wire skeletons, this metal skeleton also goes into a mold to be encased in silicone. The arms attach with square section brass tubes, so they can be easily interchanged with a few turns of an Allen key. Certain puppet movements require rigging. A rig is a device which enables animators to raise the puppet off the floor of the set to perform jumping and skipping. The animator can incrementally lift or lower the rig to any height and lock it there. There are many preparations before shooting begins, such as lighting, puppet positioning, and set dressing. Using the animatic playing on a monitor as a reference, the director and camera operator frame the shot. Meanwhile, the set dressers prepare the next set, gathering whatever scenic objects they need from the set dressing kit. To create these objects, artists first sculpt the shapes out of modeling material. They create a mold from which they produce copies in fiberglass or quick-setting resin. Then they paint the copies. With the set dressed and approved, the animator can begin. With great care, referring to the animatic, he positions the rigged puppet. Then, with the push of a button, he shoots a frame, or in animation lingo, grabs the frame. Next, he moves the puppet incrementally and makes slight changes to body positioning, and grabs another frame. 25 consecutive frames equal 1 second of animation. The animator's art is knowing how and by how much to move the puppet to create lifelike movement. To get special close-up facial shots, which they'll later intercut with the full body sequence, they sometimes set the puppet on a rig positioned directly in front of the camera. Once they've shot the animation, they take what's called a plate, a shot of the set with puppets, props, and rigs removed. They send the plate digitally to the editing suite, where the editor uses the visuals to cover up the rig, essentially erasing it from view. This process is called compositing. A little bit of behind-the-scenes artistry to create a whole lot of on-screen magic.